there you have a little README where you can follow this link to the branch where I have set up all the playbooks that I will be using to run this workshop. So if you go here to doc.tabconf, there you have a README with a little explanation of what we will be doing. And there are like 3 playbooks that you can use to follow this workshop with me. One is if you have NICs, you can try to set it up. I wouldn't recommend it to do it now, but it's like the connection is not good, so probably it's going to be slower and it's going to take you longer than this workshop. But well, you have all the steps to reproduce what we'll be doing here in those playbooks. If you try the Signet playbook, that's set up with NICs. So if you have NICs, you can run NICs develop. It will bring all the binaries that you need for to run this workshop there. And if not, you can run the Rectest playbook or the non-NICs playbook. I would recommend to, if you cannot set up NICs, to run the non-NICs one, because there you have to install the dependencies by yourself, Podman, the raster toolchain, and just the recipe runner. And yeah, with that, you'll have all what you need to start executing the steps in the playbooks to follow this workshop. So I will set up mine. OK, here we are. OK, no Bitcoin instance here. So here I will be launching my own setup. I'm using the NICs, the Signet playbook. Give me a moment. I will show you a presentation where I present myself, and I will explain a little bit more. But first, I need to set up the environment to launch the workshop. OK. Well, I don't need all those things for the presentation, so I will continue anyways. This is right, OK. So welcome to this workshop. I will be talking about integrating silent payments in BDK, the advances and the challenges. I'm Nymius. I have been contributing to BDK for a couple of years now. And since last year, I have been funded by BDK Foundation to focus on the development of silent payments and the integration with them into the library. What I have been doing up to this point is mainly working on trying to find the missing gaps that we have on BDK and try to build something, a proof of concept of what could be silent payments integration in BDK. And that's what I want to show you today. So what we are going to do here is I have set up this workshop so you can do a round trip, a SAT round trip between a BIP32 wallet and a silent payment wallet implemented with BDK. And you can send back the sats that you receive on the first transaction to the BIP32 wallet. And there you will see different things that we have related to silent payments, like the change, some difference that we have with BIP32 way of doing wallets. For example, we have a different way of derivating the change. And we will be using commands on BDK CLI. That is a tool that BDK has already developed. And I have integrated some commands there to send to a silent payment wallet. And we are going to use also SP CLI. That's the tool that I have been working on. And that tool allows you to scan for silent payments, for received silent payments, to spend those silent payments, and to scan using, the scanning is performed with compact block filters. Yeah, we are going to also verify that we are deriving correctly the change output. that we can create with our wallet. So yeah, that's mainly it. The first step to run this workshop is to launch the environment. So has anyone here run through the stage 1 of the workshop, like on the README? Has anyone tried? No one? Okay. So I guess it will be just me. It's hard to set up all this right here. So let me check that everything is in place. I got an error at the beginning, so I should try to do it again. What we'll be using, or the workshop is using a Signet node launched during this Nix development environment, so I should make sure that the Signet node is running correctly, so I can interact with it. Mainly for the BIP32 wallet, so I will try this again. Okay, so now we are launching, again, a Bitcoin Core instance. At the same time, I'm launching because I wanted to do this running on Signet and to have a fallback. If you cannot run on Signet, you can test it on Rectest. I'm launching also a container, spinning up an instance of a Bitcoin Core node running on Rectest with some other features that we need for silent payments, like a tweak server, because we need to get some shared secrets from there. So this is like if you try it later, this is like what you will see if all went well. So there I'm requesting some block filter peers, like scrapping some filter peers, compact block filters from the Bitcoin node that is running on this setup. And I need that because I want to use compact block filters to do the scanning. So I must ensure that I have a compact block filter peer available to request the filters from. And yeah, now I will continue with the presentation. This is how a correct setup will look like if you run it later. Okay, coming back to the presentation now. So I already explained what we are going to do. If you want to try this later, I'm going to use Padawan Wallet as a faucet. It's also a project developed with BDK, and well, it's like a nice tool to learn about Bitcoin if you want. So here we are going to check that everything is working. So we have our Signet node running. I'm going to check the balance. I have already sent some funds to this wallet to make the things faster. And so this Signet BDK wallet is an alias to the BDK CLI wallet. This is our BIP32 wallet. Sorry, I'm looking at you. Some of you are squinting. You need to make this bigger, or you see it right? It's okay? Okay. Well, so this is our BIP32 wallet. It's mainly, what I will be using here are mainly CLI commands. Yeah, so we have funded our wallet already. This Signet SP is our silent payment CLI wallet. This will be the one that we are sending funds to. And we will be spending those funds later. First, what we are going to do is ensure that we have the latest state of our BIP32 wallet, so we are going to synchronize it. Then, what we want to do is to fund our wallet. If you don't have any funds, we already have it, but I will show you for the sake of the example. So here, on the screen, you will see that I'm deriving an address for the BIP32 wallet, and I'm getting a QR code where I can send some. It's a QR encoding of the address of this wallet, and then you can send some funds to this wallet to start working on this workshop. Also, something that I forgot to explain is that on each of the playbooks you have stages. So all the playbooks are organized on the same set of stages. Each stage performs a different step. So first we are going to fund our wallet, then we are going to create that silent payment output and send to that silent payment and broadcast that silent payment transaction. So we can, in the third stage, scan the blockchain and find those outputs. Then we are going to create a transaction spending those outputs. And before broadcasting the transaction that is spending the silent payment outputs, we are going to verify that the change that transaction is producing is what we will actually want. And after that, we are going to broadcast the transaction and show, and you will see that it's possible to spend a silent payment output using this wallet. And if you follow along the playbooks, you will see that each one is separated on stages with multiple steps. And each one of the steps is a command where I recommend you to execute it step by step, not as a script. And yeah, each of the stages is separated equally, so you can find the matches between the different playbooks, or all of them like perform the same actions, but you have little nuances on the steps. So here we are, where we are trying to fund our silent payment, our BIP32 wallet. And I'm not going to fund it today because it's like the connection is slow, but I have some funds there. But you can try that later. You will use whatever Signet wallet you have. You can send the funds there, and you will see after a couple of minutes that it gets the funds on the wallet. But here I will try to do a recap of what are silent payments about. So the idea is that here we will be waiting for confirmations. Let's suppose that we are doing that. So in silent payments, what we do is we have two public keys. One is for locking the funds. The other is to produce a shared secret. So we can add some entropy to the address generation, and in a non-interactive way, get a new address each time with just sharing a static code. And what the sender does is it receives those public keys, creates a transaction doing some coin selection. It has an input, a set of inputs, hashes that data, some data of the inputs, to produce a digest of the transaction inputs, then gets the share secret public key, the public key that is going to use to produce the share secret, combines that with the hash of the transaction input data, and then it combines that with the locking public key. In that way, it produces a unique script key that is it can only be found by the recipient. And the way the recipient knows about this, let me go back to the original. The way the recipient knows about this silent payment UTXO is by getting the transaction input data, hashing it again, combining it in a way that it can produce the same share secret. And by combining with the locking public key, it can find a match against the script key that should be the desired, the original derived by the sender script key. So, yeah, this is like a very short explanation of what silent payments are doing. And now The idea is that here, after you send the funds to your BIP32 wallet, you are going to get, you have to synchronize again your BIP32 wallet to see the funds actually on your wallet. So if we would have sent the funds using the Signet faucet, now that we run a balance, we will get new funds. Well, actually, someone has sent some funds there. So untrusted pending is there is a unconfirmed transaction that is sending to this wallet. Someone has done that. Thank you. Thank you. So yeah, we should wait a little. testing. Okay. We are here. I'm going to repeat some of the commands. I don't know what that is. It's going to screw all the scripts. So if not, I can continue just by executing the steps myself on the terminal. But it's not going to be that nice. Okay, somehow I guess something is messing with my clipboard, and I was using that as a way of transporting the different variables between the slides. But I guess I can follow one of the playbooks and show you here step by step, following the presentation, how it's done. So we derive our silent payment code. We have our silent payment address, and we want to create a silent payment output. So we use this create-sp command from bdk-sp wallet. And let me go to the Signet playbook, where I have the steps that I need to create this. So we get our silent payment code. Not this one. Okay, that's why it's not working. Something has with the screen has broken my clipboard, and I cannot share. It's like crazy, but yeah, it is what it is. Okay. Okay, do you hear me? Okay. So I will have to type it myself. Okay, so we are going to get our code here. So if I show you here, well, we have our address here. Let me do it again. You see the address, the human real prefix, a delimiter, and one of the public keys is here, and the other one is following it with a checksum at the end. Now, I have already explained that this is a BEC32 encoded string, and we will create our transaction right now. Okay, now we have to create our transaction. We'll use the create-sp-tx command. That's a new experimental command that we are adding to BDK CLI. We are going to send 5,000 sats with a fee rate of 2. I don't know what is the state of the mempool in Signet, but just in case. We are going to add our string, and this should have created our transaction. Okay, here we have our transaction, our raw transaction. This transaction has a silent payment output that we have derived of our original address. Now we are going to clean that up a little bit so we can broadcast it easily. Okay, let's see that we have what we want. And there you can see that we have an up return, and the other one is the silent payment output that we are deriving here. As you can see, this is as any key path spend. Well, you cannot guess that from here, but it's a taproot output. So it's like any other pay to taproot output out there. Now I'm going to broadcast this. Maybe it's easier to do it with the CLI. So okay, now we have this this TXID. We can see if it is published in the, if it is on the mempool. Okay, as we wait. So now with this command, we have derived a silent payment output that this transaction is sending to a silent payment wallet. The way that we did this is by the create-sp tx command just creates a PSBT, adds some placeholder pay-to-taproot scripts, and it uses those pay-to-taproot scripts to perform the coin selection based on the PSBT. And once we got the inputs, we get the necessary data to derive the shared secret that we are going to use for the derivation of the output of the silent payment transaction. So we perform like 2 steps. One, we add the placeholders pay-to-taproot scripts, the outputs. We perform coin selection. We get the inputs. We get the private keys for each of the inputs. We derive the shared secret, and we get the final silent payment output by hashing those inputs. And after that, we sign and finalize the PSBT, and we can send the transaction as any other transaction. One of the things that we have to do before is we have to derive, like as I said, we have to perform the coin selection, and we add the placeholders. But we derive first, before signing the transaction and broadcasting, we derive the silent payment outputs. So there are some steps that we do. In BDK, we have the derivation path for each of the inputs on the PSBTs, and we use that to get the actual keys on BIP32 wallets. We need also those on the derivation, on the silent payment derivation, because they give us important information for knowing what keys we must use for the silent payment outputs for the silent payment derivation. So we must re-add them after the finalization on the previous step. And there are some, for silent payments, we have a subset of the available output scripts that we can use we can use to create this shared secret. So what we are doing is we are after getting the inputs, we are filtering them and looking if we can derive a silent payment output from these scripts. Here, I'm showing you, well, probably this is not relevant, that much relevant right now, but once we got the derivation path and we get the public keys from the private keys that we are going to use to derive our silent payment output, we have to, we add all those keys and we get the smallest lexicographic outpoint, and we combine that together and by combining them and later adding them to the public key of the silent payment output, the public key for shared secret derivation, we get the first part of the output. Then we add the public key locking key. So after doing that, we retrieve the control to the creates silent payment transaction. We remove the previous signatures because we are going to sign again the transaction, and we finalize the transaction and we finalize the PSBT and we get the final transaction. So here I do some why I'm signing I'm finalizing before the silent payment output derivation. Well, because currently there is no, the specification for PSBT is not finalized for silent payments. So I'm doing this, I created this transaction in a sort of hacky way. And what I'm doing is I perform the first step so I can look at the witnesses of the first transaction. So I can know if I can get a silent payment output from those keys. In the case, for example, of a script path span that has a nums point, that's something I should know to know if I can get a silent payment output from that input or not. So I implemented this hacky way of looking at the witnesses of the first transaction to get the final output. Also, after performing the signing of the PSBT, I'm reattaching the finalization. I'm reattaching this key derivation data, and that's because I need the information to get the actual keys that I need, the actual private keys that I need to derive the shared secret. And well, that's also part of the hacky way that I'm using to create this transaction. Well, creating the signatures is obviously, I'm going to add a new signatures after deriving the actual silent payment outputs, so that's why I'm doing that. And an important point of this command is that I'm not producing a PSBT because I don't want anyone to share this PSBT for later signing of other parties. The multi-party implementation of PSBT is something that is not available right now. And I don't want someone to think that it is possible with this command to create PSBTs that they can share between multiple parties, because they are going to lose funds if they do. Okay, so coming back to the terminal. Right now, I have sent the funds to the silent payment wallet, but I want to find those outputs. So what I'm going to use is compact clock filter together with a blind bit server. That is a way to get the shared secrets already derived for each of the transactions. So I can request this secret without having to compute it myself on the wallet. And it's a way to perform this scanning faster for silent payment wallets. Here I'm adding an extra peer that's to get actually compact clock filters from someone, because it's not that easy to find a compact clock filter peer on Signet network. So here we see that we have a successful connection and handshake with a peer, so we must wait to update to the latest tip on the compact law filter client before starting to request the tweaks. Yeah, so this is going to perform a scanning of using the compact law filters, getting the tweaks, producing the script keys that could be derived by our silent payment address with those tweaks. And if it finds a match, it's going to request the full block, and it's going to perform the whole, it's going to scan the whole transaction to see what are the outputs that belong to the wallet. So, well, this is going to take some time. Let me. As we continue with this, I can explain you and show you some of the other parts of this. So the expected step to perform after this scanning is to check the balance of the wallet. I already have some funds, so we have not find the recent transaction that we have done before. Let me see if, okay. I have it on my, yeah. Here. That's not confirmed yet.
You have to go to Signet. That's my.
Oh, yeah, sorry. Thank you. Yeah, this workshop is not prepared for mainnet. If you want to do it on your own risk. I wouldn't recommend that. Okay, so it's unconfirmed. So it's not going to be found yet by our scanning. So we can proceed and see if this finishes later. So probably one of the problems that we have here is that Signet doesn't have that many peers, and well, it's not of something that you can. It's hard to find it actually, and they don't service the filters that much. So yeah, on this step on the playbooks, it's expected for you to have find the silent payment output, and like you should see. Well, actually, the previous transaction got confirmed, so my balance on the BIP32 wallet has risen, but yeah. We have already found, or let's say that we found a silent payment output. So the next step that we are going to do is we are going to send back the funds from our silent payment wallet to our BIP32 wallet. So the way that we do that is, let me open a new terminal as we wait that to finish. Okay, I will copy this command. I'm doing all this because my clipboard isn't working. Okay, so now I should have, say with address here. Okay. And in this step, what I'm going to do is I'm going to create a transaction that is sending from the silent payment wallet to the BIP32 one, and in that way, I'm going to take one silent payment produced output and spend it on my transaction. So to ensure that I have a change output, I will use the balance that I have. I'm going to remove some I want to subtract some amount for that from that balance to ensure that I'm not sending all my funds and I don't have a change output. Okay. Should be fine now. Okay, I have the amount now. Good. I'm going to add this up return so you can later check the blockchain. And now I'm using the command new tx from signed.sp. I'm using the BIP32 address with the amount. Now I add the up return. Yeah. Sorry. Thank you. UTX, that's the command. Fee rate up return. Well, the connection isn't helping. I'm going to close this one. Yeah. Probably something with the network. I can show you later, like I can show you in Rectest in a moment, but yeah, it's not going to work here. Okay. So yeah, we have our silent payment, our transactions pending silent payment outputs here, and I'm going to extract some of the data from here to make it easier to broadcast. Okay. Now, this is our transaction. And well, what I wanted to show you is that you can actually derive the change output of your transaction by using the command line that we have on the SPCLI wallet. There is a command called derive SP for transaction. And if you add the, like, for silent payments, you can derive an output at the beginning, like you can derive the first output, the second output, the third output, because you have a parameter there that changes the actual script key for that output. And you also have labels. Labels are not recommended in what we will do with labeling some food or labeling an address with, well, we will use this to send transaction to our grocery stores or whatever. No, labels were something that at the beginning was thought that it was going to be useful in that way, but it's actually something that adds more performance issues to the scanning of the silent payment outputs. So what we is actually recommended for is just to derive the change output, especially on mobile wallets. So what we are going to do now is use the special change label that is designed to get the change script output. And we are going to check that the transaction that we have created before has the same script key that the one that we are getting in with this command. So I add the order, I add the change label that is going to, the change label is 0, is specified in the silent payment BIP. Well, we have a new block there. I guess I can try later to scan that. Okay. Yeah, so we are going to use the raw transaction here. This is getting the information from the raw transaction, is scrapping all the inputs, combining them in to get the hash that is used to produce the shared secret, and is combining that with the public key information that we have on our wallet to produce the final script key. So let's see here. we can see a script up key, the script up key that would have been derived for our change output. So if we copy this transaction, the raw transaction, if we decode it, and we go to our previous script up key. Let me see. Yeah. Okay. Yeah, we had 3 outputs. So one is the op return, one is the amount that we want to send, and the other one should be the change. So I'm going to copy this previously derived change output. Okay, and here we can see that it's the same one that we obtain on our transaction. So with this, we are confirming that we actually have derived the correct change output for our transaction. So now we can send again our transaction that is spending the silent payment output to the, like we are broadcasting our transaction, so should be mine in a few minutes. And in that way, we will be spending actually the silent payment output that we have scanned before, I have scanned before. Well, I guess the scan missed some of the, I should have scanned before doing this because it's like using all the inputs and the network is not going to help. Okay. Well, it's not going to help me there. Okay. Well, with this command, we will have created a silent payment transaction, a transaction that is actually spending a silent payment output. And what we have now, and we have verified that we are producing the change output right with our derived SP for transaction command. And let's suppose that we have broadcast our original transaction. And what we are doing as with this scan CBF command that is not connecting right now because, well, problems with Signet, but we are using Kyoto CBF node to listen and store the filters. And with each filter that we receive, we request silent payment tricks for another server, BlindBit server. That's the one that is computing the tricks for our wallet. And with each one of these tricks, we can get derived the script up keys that we want to check if they belong to our wallet or not. And if we find a match using compact block filters, we request the full block, and we index that on our wallet, and that gives us the actual balances that we have on our wallet. So all these processes repeat from the birthday of the wallet up to the tip of the chain that we have. We are synchronized to. The new TX command is a command from the silent payment CLI wallet, and it's very similar to create SP transaction, but the difference is that we are spending silent payment outputs. So by spending silent payment outputs, we have to add raw tweaks to our private keys to be able to spend them, and it's something that is not implemented yet for PSBT, and it hasn't been that much of a specified. So what I'm using to perform this tweaking is adding a proprietary key to the PSBT structure, and by passing that to the wallet, by adding the tweaks for each one of the silent payment UTXOs, I can then combine that tweak with the spending public key, and after doing that, I can get the final private key that is going to allow me to produce the shared secret again, to also to create a new change output and to send to a BIP32 wallet. This is the function that I implemented for this. As you can see, this is using a proprietary key, so that's not that. It's not that. Well, this could have his own field, so that's something that I would like to point in a future. We could be doing a specification to add this new field for raw tweaks for silent payment outputs. And after doing that, after adding this information, we can perform the same step that we performed for the BIP32 wallet, but on the silent payment one, actually deriving in the same way the silent payment outputs. Okay, I have shown you this. So after performing this step, we should be scanning again with Signet BDK, the BDK CLI wallet, the BIP32 one, to see if we have received the funds from the silent payment wallet. And we should perform the same scan, but for the silent payment wallet, to see that we have spent the funds on our wallet. Okay, I haven't followed the steps on the previous command, so I'm not going to run this. But the expectations is by the end of this, by performing all these scans, waiting for the confirmations and all that, you are going to get the actual silent payments output found on your silent payment wallet, and you are going to find that you have spent the silent payment output later. So what I will do, as I couldn't run the examples on Signet, I'm going to show you and talk you about the challenges that I have found, the things that are missing from the upstream libraries for BDK, and then I'm going to run a reg test example to show you that this is actually working, and this or more of a sudden error here that I couldn't fix on while running this. So the target of this implementation was to try to build something with BDK, showing that it's possible to build a silent payment wallet using BDK, and to have a fast feedback loop and a good comprehension of the landscape of the state of a silent payment, the silent payment integration for BDK now. And this allowed me to gain recognition of the different things that are missing in the upstream libraries, and what we should implement first on the different libraries that BDK is using to have support for silent payments. So what were the challenges of this? Well, actually the elliptic implementation for silent payment is not merged yet. So there have been some advances on the bindings, but we're a work in progress. And for me, it was hard to implement the integrations with that. So I implemented a library completely written on Rust to start building this wallet. And also there is, BDK is a PSBT-centric wallet, is performing creating transactions by passing PSBTs during different stages of the wallet. And silent payments has not the specification yet for PSBT. Those are the BIP 374 and 375. Those are the ones that we are waiting to have something that we can build on top for PSBT and silent payments. So they are not there. They are not finalized yet. So that's why I have to use this tricky, hacky way of doing the transaction to actually be able to create silent payment outputs using PSBTs. Well, also what I have said before about this signing phase of that we need for silent payment wallets to create to spend the silent payment outputs that we have on our silent payment wallet. That requires some the tweaks, and there is no field to pass the tweaks around in PSBT right now. So that's something that well we could specify also. And in BDK we don't have a way to store the information that we need to derive this shared secret that we are using in silent payments. So that's something that I'm also looking to implement or in some way integrate in BDK. And with this, I think that we could have a nice abstraction for both that can be used for BIP32 wallets and silent payment wallets. So as I said, the PSBT specification is mainly focused, well, it's also designed for multi-party transactions, and we didn't have the security assurance there to do this for silent payments yet, so I decided to simplify the case and just use PSBT as a way to do single-party transactions. So in that way, I make the proof of concept of what I wanted to achieve at first on this with this project achievable and unrealizable in the span of time that I was seeking. So the next steps that I think that we should have for the implementation of LXP of silent payments is the integration with the bindings. I think that is well, once the PR for libsecp gets merged, it would be nice to have this binding on Rust so we can start using the actual more secure library. Also, I would like to specify this the addition of these fields for raw tweaks on the PSBTs. In that way, we can pass around these tweaks and we can create the transactions easily for silent payment wallets. Also, the addition of the features that the BIP for PSBT and silent payment will bring, that's something that we should also try to start experimenting with. And well, there are some other things more related to how things work on Rust, on BDK and Rust Bitcoin and Rust PSBT that are also related to the PSBT process of creating a transaction that I would like to add in the future. So one of them is this key request that is used to sign transactions. Some more information added by extracting that information from the silent payment descriptors to be able to perform this in a more streamlined process. And yeah, one of the main changes is the addition of the metadata attached to the transaction that we are storing on BDK.
Quick question.
Yeah.
So last month we did a demo of Frost with BDK,
Mm-hmm.
and we too had problems with how BDK kind of takes over how adapters work. We had problems with Frost and how BDK makes it difficult. So we ended up having to hack BDK a little bit to do it. So when you're working on your own kind of suggestions around, how BDK can improve and handle adapter signatures, you might want to look at what we did. Let's come up with a generalized solution, because I think this is going to be an ongoing problem as new protocols are emerging and we want to integrate them with BDK, that the fact that it does some things with adapter signatures kind of underneath isn't compatible with everything.
So I guess you find your own workaround for that on what you were trying to do. I didn't
Correct. We had to write one to basically extract it out because BDK didn't let us do it right, and then another one to insert it back in. So we had to write a little Rust stub that did both of those operations. Mm-hmm. When we should have just been able to say, we're going to handle the adapter signature. You don't need to. anyhow, I'm just going to suggest you look at when you're working on your own solution for that you might want to look back at the code that we have on our website at Blockchain Commons on this,
Okay,
and see if we can, and then, I think that it's a general problem, because I look at some other future emerging protocols, and I think other people also may need that flexibility, and it's not really thought of in the BDK.
Yeah, that's good to know, actually, because I was thinking in implementing this in a more general way, trying to not just focus on the data that we need for silent payment transaction, but in like something that can be used by other protocols. And yeah, that's actually something that fits that description. So yeah, thank you.
Thank you.
Okay, so yeah, he went ahead and already asked questions, but well, there have been some problems here in the presentation, but I'm happy to answer any question that you have now. Yeah, there is one there, another there.
So I looked at silent payments a long time ago, and then back then one of the issues was for receivers, it takes out a very long time because they have to scan the block at a certain block height and look for like their public key, like basically scan the blockchain if their public key received any funds. Has there been any like progress on speeding that up by any chance since then?
Yeah, well, one of the approaches that was recently tried is the one that Frigate is taking, is like using a kind of a special databases that just perform the tweaking of the information already on the database, so it's like faster, but it's something that doesn't bring you to what we want to be in terms of performance. So another solution that was discussed is the use of tables, pre-compute tables, to get some of the elliptic curve multiplications faster. Well, and also I don't want to like start using buzzwords, but now it's like maybe it's a problem more fit for parallel processing or GPU setup to try to speed the things up. I'm talking in terms of what would be the scenario for a server that is trying to compute the tweaks or trying to find the UTXOs for a client. If the server is performing all this operation for multiple clients, yeah, it's actually it's going to be a bottleneck, and we are trying to speed up that setup, and then once we figure out that, move to the more private conscious way of doing the silent payments. Yeah. You got the question? No, I thought you were okay. Any more questions? Okay, yeah.
Does the PSBT stuff need an update to the spec?
Sorry?
To support, are you going to update the PSBT v2 spec? Is that your plan?
Sorry, I didn't.
The BIP?
Like if we are going to, yeah.
I think he's referring to the new field that's going to be required.
Yeah, I think we need a new, because it's a different, it's for something different. I think that we need a new BIP actually, because it's for spending the silent payment outputs, and the old PSBT was to create the transactions, but it's like one is from the perspective of someone that is trying to send to a silent payment address to get the outputs, and the one that the new field that I was talking about is to be able to spend the silent payment output. So I don't have experience in how the specification should be done, but I think that it's going to be a new one. Okay. Well, if you don't have any more questions, I have 20 minutes more. I can try to show you this, but trying to run all the steps in a rec test node, so I don't have network connection problems. So let me try that. One of the things that we have here on the workshop, on the directory I pointed you, is the auto playbook. So if you run this playbook, it's going to show you a nice interface where you can just press enter, and you are going to be able to run all the steps of this workshop. So first, we check that we have all the dependencies here. Shouldn't take that long. It's also depending on the connection, but yeah. Bear with me for a couple more of minutes, and I can show you that this works. So this is installing the BDK CLI wallet and also the SP CLI wallet. That's the one used for silent payments. Okay, now we are spinning up a virtual machine that is running our containers. The container has a Bitcoin Core reg test implementation, and also the blind bit server that is providing me the tweaks running on reg test 2. So once this is all done, I can press enter again to continue to the next step. So here, I perform the usual checks. So get blockchain info is retrieving me that I am actually on the right network and is working. So I'm going to perform the same step for BDK CLI. I don't have funds because I am on a new created reg test CLI wallet. The same should happen for the silent payment wallet. I'm going to synchronize. Well, I'm going to get a new address. This new address is to fund the actual BIP32 wallet. And as you can see here, this is the actual address that I got before. I'm going to send some funds to it and then mine 100 blocks to the void so I can get the first transaction confirmed. I'm going to do that. Okay, and now I can press enter. I synchronize again the BDK CLI wallet, and once I check the balance, I have the balance here, so it's like 50 Bitcoins as expected. Now I get again the silent payment code, so here I should have like the address of my silent payment wallet or the silent payment wallet that I have running on reg test. So you can see here that I have the human real prefix that is intended for reg test, and this long address are the two public keys encoded in a single string, and I will be sending 2,000 sats. Well, at a fee rate of 5 on reg test is crazy, but yeah. So I created the previous transaction, and now I have created a silent payment output in this transaction. So I'm going to broadcast it. I'm going to mine a block. And now that I have synchronized, I can scan. But here I'm not using CBF because I'm on a reg test node, so it's going to be not that slow to perform the scanning, but just by going through the RPC interface that BDK has and checking with each of the blocks that I have received the funds. So as we can see here, we have received this the 10,000 sats from the wallet. So Now that I check the balance on the silent payment wallet, I can see the funds there. And I can see that I have spent the funds from my previous wallet. So right now, what I want to do is fund a new transaction by spending the silent payment output that I have just scanned, as I did before. So I'm using the new tx command from the silent payment wallet to send to the BIP32 wallet. I'm going to execute this. I'm also going to check that the change is correctly derived. So here I get a change output match, so it's actually working. I broadcast the transaction. I will manable lock again. And I scan again the blockchain to find that I have spent some of my funds to the BIP32 wallet. So now in the silent payment wallet, I have less funds than before. And the BDK balance, well, it's hard to tell by the number because it's very similar to the other, but I have actually received the funds. So yeah, here we can see that I have spent the funds, but I have received back some of them in change, so I actually derived the change correctly, and I was able to find them by scanning the blockchain. So yeah, that's what I was trying to show you with Signet. But yeah, you can ask me more questions now, or well, we can wrap it up now. But thank you for coming, and thank you for participating in this workshop.